Good evening, everyone. Thank you for joining us tonight. Welcome to the Avexia webinar series. Our topic for tonight is Scientific Update on Omega-3 and Benefits of Testing the Omega-3 Index. My name is Christopher Chu. I am the Director of Marketing for Avexia Diagnostics and will be your host for this evening. Today, I have the distinct pleasure of being joined by our guest, Dr. William S. Harris, who will be our presenter for this webinar. Dr. Harris is an internationally recognized expert on omega-3 fatty acids and how they can benefit patients with heart disease. He obtained his Ph.D. in human nutrition from the University of Minnesota and did postdoctoral fellowships in clinical nutrition and lipid metabolism with Dr. Bill Connor at the Oregon Health Sciences University. His interest in omega-3 fatty acids began with his postdoctoral work when he published his first study on the effects of salmon oil on serum lipids in humans. Since that time, he has been the recipient of 5 NIH grants for studies on the effects of omega-3 fatty acids, EPA and DHA, on human health. He has more than 300 publications relating to fatty acids, including omega-3s, in literature, and was an author on 2 American Heart Association scientific statements on fatty acids, fish consumption, fish oil, omega-3 fatty acids and cardiovascular disease in 2002, and omega-6 fatty acids and risk for cardiovascular disease in 2009, both published in the journal Circulation. Dr. Harris co-invented the omega-3 index in 2004 and made it commercially available to the research community and the public in 2009. To date, the omega-3 index has been used as the standard measure of omega-3 status in more than 200 clinical studies. Dr. Harris is also a professor in the Department of Medicine in the Sanford School of Medicine at the University of South Dakota. Joining Dr. Harris tonight will be Dr. Wayne Sedano, our Director of Clinical Support and Education at Avexia Diagnostics. Additionally, Dr. Sedano is the Director of Integrative Medicine Education for the College of Integrative Medicine and lectures and teaches internationally. Before we begin, just a bit of housekeeping. We encourage participation, so if you have a question, you may submit your questions in the questions field in the right-hand area of the interface. We will answer submitted questions towards the end of the presentation. If your question is not answered this evening, you will surely receive an answer by email within a day or two. Without further delay, I will now turn the webinar over to Dr. Harris.
Thank you, Chris. Great to be able to share with you and your colleagues and your viewers, of course, what's been the love of my life, over 40 years working in omega-3, and it's been a great ride. Hopefully give a very quick overview of where we've been and where we're coming from. I am in South Dakota, as mentioned. Of course, there are the famous faces. I do always like to show folks a picture of the Sioux Falls. We actually do have a waterfall in Sioux Falls. Not the Niagara, but it's not bad for the Northern Plains. So anyway, that's where I'm at, and happy to be doing this presentation for you all. So just to take a high-level look about the omega-3s and where they work. Actually, the omega-3 effects begin down here at the cellular and the membrane level, and this will become clearer as we move forward. Of course, membranes constitute organelles, organs and cells. Cells are constituted by a bunch of organelles. Tissues are made up of cells. Organs are made up of tissues, and people are made up of organs and tissues. So the idea here is that the omega-3 effects actually manifest here at the whole body, but they begin down here at the membrane where the effects of omega-3 are important. We have multiple mechanisms of action of omega-3. I'm not going to go through these all the cellular stuff in detail, but we do know that omega-3s can reduce heart rate, which is a good thing. It may explain some of the longevity issues. They can reduce inflammation. They can slow telomere shrinkage. So there's kind of an anti-aging effect. They're antithrombotic, somewhat like aspirin, except safer. And they certainly are triglyceride lowering. So we know that they lower lipid levels. And they do probably much more that's harder to explain. Just a quick look at this slide of the cellular mechanisms of action. The omega-3s really start their action in the membrane, the cell membrane. They become part of the phospholipids in the membrane. And from there, they affect multiple cell systems that I'm not even going to begin to go into at this point here. Suffice it to say, that's where the action is. So interesting, a couple of, about 6 months ago, I put together the slide looking at the most researched molecules in medical history. And I did this with the help of folks at the Global Organization for EPA and DHA, which is the trade association for omega-3. Omega-3 fatty acids, really, if you look at, so the orange bars is the number of papers, and the green, the blue bars are the number of randomized controlled trials within that context. Penicillin, vitamin D, aspirin, prednisone, and folic acid and omega-3 are about the top 5 researched molecules in terms of history. So it's a huge amount of literature, over 40,000 papers on omega-3 fatty acids. There's a tremendous amount of evidence. And so we're going to go through a very, very, very small piece of that here today. But suffice it to say, there's been sufficient interest in omega-3s to result in this kind of research. What we'll talk about is omega-3 and longevity and cardiovascular disease, autoimmune diseases, a little bit of mental health. We'll touch on exercise and joint pain, some eye health, particularly macular degeneration. And the topic du jour, of course, is COVID-19, which is sort of fading, thank God, but it's still of interest as a case study for omega-3 and inflammation. And we're going to talk about the omega-3 index. Many of the studies I'll talk about use the omega-3 index as a marker of omega-3 status in the blood or in the tissues. So what is the omega-3 index? It is a measure of the amount of EPA and DHA. Of course, those are the two marine or basic omega-3 fatty acids that I'm focusing on today. These are the ones that are found in fish oils, of course. So we're looking at the amount of EPA and DHA in red blood cell membranes, and it's expressed as a percent of total fatty acids. So in this little cutout cartoon of a red blood cell, we look at the lipid bilayer. We have the outer layer and the inner layer of phospholipids, and in this particular cartoon, the red ones we have kind of identified as omega-3. And so, there's 64 different fatty acids in this membrane. These little hangy down or pointy up things are the fatty acids. The balls are the head group of the phospholipid. So out of the 64 fatty acids in this particular little cutaway, 4 of them are omega-3, EPA and DHA. So 4 out of 64 is 6.25%. So that would be the omega-3 index of this particular, the blood cell or the person from whom this blood cell was taken. That's a little higher than the average in America, but it's quite a bit lower than the average in Japan, where they eat a lot more fish. So when we talk about the omega-3 index, it's going to be in a percent, and it's going to be a percent of EPA and DHA in cell membranes. There's a lot of data here, and I don't need to go over all of it. The point is the EPA and DHA content of red blood cells reflects the omega-3 content of most other tissues. And these are data from rats, or mice, I believe, looking at, here, as you can see, multiple different muscle, spleen, but all these different tissues. The higher the red blood cell omega-3 level, the higher the organ level of omega-3. So what this basically says, we've done this in humans too, but it's easier to do in animals. The higher the omega-3 level in a red blood cell, the higher the level in other tissues. So it's a good reflection. And of course, red blood cells are much easier to get than any of these other tissues. So that's a great reflection of whole body status. So what's the scale of the omega-3 index? What's normal? What's ideal? We say a desirable omega-3 index is somewhere between 8 and 12% up in this area. This is kind of an area that's typical for Japan because, again, they eat so much omega-3. America and Western Europe typically have levels in the five-ish area, between 5 and 6. There's certain groups that have under 4%. That's a really undesirable level. But again, this is where we are. Where we'd like to be is up here in the Japan area. So when you get an omega-3 index test from Omegaquant, this is roughly what you get. Is, of course, you'll get your particular level on a scale, the very standard stoplight scale, red, yellow, green. It'll tell you where you are and where you should be. Again, 8 to 12% is the optimal level. Most people in the United States, like 95%, are under 8%. Even if they say they supplement, we'll look at a little bit of data on that. Certainly, different genetic factors and absorption can affect blood levels, and EPA and DHA dosage should be based on blood levels. That is to say, if you're going to be wanting to increase your omega-3 index, you have to do it with increased intake. So what are some of the things that affect the omega-3 index response to a supplement, besides simply, of course, the higher the dose of EPA and DHA, the higher the greater the effect on the membrane levels. Fish, of course, do your patients eat fish regularly? The more fish and oily fish that they eat, the better. That will increase their omega-3 index. If they're taking a supplement, there's different forms of EPA and DHA. There's ethyl ester forms and there's triglyceride forms. And the ethyl ester forms typically are not quite as well absorbed, particularly if you're not taking them with food, compared to the more natural triglyceride form. So that can affect the way your omega-3 index responds. It's a comment I just made. If you take your supplement with food, you're going to absorb it better. Might not be absorbed, especially if it's an ethyl ester. But in any event, any omega-3 supplement should be taken with food so you get the full advantage of all the digestive enzymes to absorb these fats. And interestingly, very intense exercise we've seen in our studies appears to lower the omega-3 index. So that might be a reason to actually be taking more omega-3 if you're very active. Looking at the question of how supplements versus fish intake affect the omega-3 index, these are data that we published a few years ago. On the y-axis here is the omega-3 index. These are data from about 3,500 samples that were submitted to Omegaquant, dried blood spot samples, and in which the people who were submitted answered a few questions. And some of the questions were, how do you take an omega-3 supplement? Yes or no. And how much fish do you eat? How much, oily fish? And this is not just any kind of fish. This is fish that you would bake or broil, typically oily fish. And what you can see here, if you just focus on the light blue bars, not the dark blue, the light blue bars, you can see that the omega-3, and this is people who are not taking omega-3 supplements. So the average omega-3 index of people who are not taking omega-3 supplements and are eating no fish is around 4%, 4.3%. So it's low, definitely low. But as the fish intake goes up to 3 times per week or more, then you see the omega-3 index gradually going up, which is a good validation of the biomarker. If we didn't see this, we wouldn't trust the omega-3 index, but we know that it makes a difference. The dark blue bars are people who are taking supplements. And so people who are taking supplements but not taking any fish, their omega-3 index is about 2 units higher than people who are not taking supplements. And on average, that's the way it goes. The blue bars also ramp up based on fish intake. And you can see here that the recommended intake, like for the American Heart Association, 2 times of fish per week, 2 times a week of eating fish. And the American Heart Association, of course, is not recommending supplements, and they never do. So this group has an omega-3 index of about 5.8%. So you're certainly not going to be up to 8% if you're just eating fish twice a week and that's all you're doing. So if you really want to get over 8% on average, you actually need to be eating fish 3 times per week and taking a supplement. Now, clearly you can just take a supplement and not eat fish at all. I mean, let me back up, sorry. Here's people, I mean, the average omega-3 index in the group that's not eating any fish is 6.7%, but the standard deviation is pretty large. Some of these people have an omega-3 index over 8%, and they don't eat any fish, they just do it by supplements. That's certainly doable. On the other hand, you can eat just fish, and here's an average level of 7%. People eat 3 times a week, but they don't take supplements. You can certainly get a healthy omega-3 index just from eating fish. So both ways are possible. We have on our website at Omegaquant a calculator that gives you some suggestion for how much EPA and DHA you need to take to add to your diet to increase to get up to an 8%. So what we would do, it really depends on what kind of form you're taking. In this case, you would enter on our website, you would enter your current omega-3 index, whatever it is, and then this would tell you, if you don't put any, how much milligrams you're eating per day. If you don't know what form your omega-3 supplement is, we're going to assume that it's going to take about 1,900 milligrams of EPA plus DHA per day to get you from 4% to 8%. If you're taking a triglyceride form, actually, this would be the same answer if you were taking an ethyl ester form. Taking a triglyceride form of omega-3 supplement, you would need about 1,270 milligrams to go from 4.5% up to 8%. So it gives you a rough idea of where to start. Although everybody is different, and you really can't bank on this completely for being accurate. You really just have to keep retesting until you titrate yourself to the omega-3 index of 8, and then stay on that dose. So that's a quick walkthrough on the omega-3 index and some of the factors that affect it. Let's now look at some of the evidence for the health effects of omega-3 fatty acids. We're going to start with the most important one, living longer, longevity. And I'm going to present the data from a study that I was the lead author on last year, published in 2001 in Nature Communications. And here we looked at omega-3 levels and the risk for all-cause mortality and cause-specific mortality. That is to say, we looked at risk for death from anything and the risk for death for cardiovascular disease, cancer, and other things. The study we did included prospective evidence from 17 different observational cohorts, like the Framingham study, like the Women's Health study, like the MESA study, like Eric's study, a variety of these observational cohorts where we have omega-3 levels measured at the beginning of the study, and then we look at who dies when as a function of their omega-3 levels. So in this particular paper, whoops, sorry about that, we included 42,000 people, 17 different studies from 10 countries. Their average age was about 64 years old. They were about half of them were women. Across all of these different cohorts, they were followed up for an average of about 16 years. So fundamentally, we're looking at what's the relationship between your omega-3 level in your blood and your risk for dying between age 64, that's where it started, and at 16, that's 80. So in that window of time, a certain number of people die. Obviously, if you wait long enough, everybody dies. So you don't do that. You look in a fixed window of time and look at what's the mortality during that range. We found in our study, we had about almost 16,000 deaths occurred in those 42,000 people. And 30% of those deaths were from cardiovascular disease, 30% were from cancer, 39% was from everything else that you can die from. And so the question we were interested in was how is the omega-3 level in all these studies related to risk for death? And here is a kind of a complex slide. I'll explain in a minute. The title here is a comparison of risk for death from any cause. And we're talking about all-cause mortality comparing the 90th percentile to the 10th percentile of EPA plus DHA. So blood levels of EPA and DHA is what we're measuring. And we're asking the question, if people who are in the 90th percentile, the highest levels of EPA and DHA, compared to the lowest, roughly the 10th percentile, what's the difference in their chance of dying over this period of time? And these are all the different cohorts. They all have different acronyms. There's no point in going over all this. But you can see how many people, how many deaths were here. Some people in these studies, so some studies measured plasma phospholipids or red cells. Some measure whole plasma, some measured cholesterol esters. It didn't really make any difference. The omega-3 levels are correlated across all these different lipid pools in the blood. So we are able to pool them together. This little diamond here is really the most important piece. And what this says is this is a hazard ratio of 0.87, which means that what that translates into is that the risk for death from any cause was 13% lower in people who had the highest versus people who had the lowest omega-3 index. And we adjusted for many, many other risk factors, obviously age, sex, race, history of heart disease, history of diabetes, blood pressure, cholesterol levels, etc. These are all adjusted for. This is independent of all those other factors, smoking, etc. So what we found here was a very strong relationship between the omega-3 level and risk for death. In the same study, we also looked at, as I said, all-cause mortality and cause-specific mortality. So cause-specific, meaning what did you die from? Did you die from cardiovascular disease? Did you die from cancer? Did you die from something else? And this is what we call a quintile analysis. So we look at the 5 different levels of omega-3 levels. So people in quintile 1 had the lowest omega-3 levels. Then each group is 20% of the population up to the highest quintile, Q5. They had the highest omega-3 levels. And again, if we look at all-cause mortality, you can see that the higher, for each group of higher omega-3 levels, the risk for death drops very monotonically, very dose-related, very strong evidence that omega-3 is related to this. We look at cardiovascular disease, we get the same effect. And we look at cancer, actually, there's not as strong an effect as with cardiovascular disease, but actually people with the highest levels of omega-3 were less likely to die of cancer. And interestingly, if we look at all other causes of death combined, besides cancer and cardiovascular disease, there's still that relationship. So it's not, the omega-3s are not just heart disease related. They are related to risk for death from anything. And that just means they operate in a very global, very systemic way, which benefits all levels of health, not just cardiac health. Again, I mentioned some of the studies that were included here didn't measure the omega-3 index. They measured plasma omega-3, for example. But if we estimate what is quintile 1, if we use an estimate of the omega-3 index, it'd be around 3.6%, and quintile 5 would be around 7.8%. So again, this sort of validates our original proposal back in 2004 that a value under 4% is bad, and a omega-3 index around 8% or above is really the target. And this actually confirms that very nicely. So we see that higher omega-3 associated in the biggest study ever done on this question with lower risk for death within a window of time. Here's another study that asks the question in a very different way. This is called the UK Biobank. This is the United Kingdom, has started about 10 years ago, recruited almost 500,000 people into a long-term study that looked at a variety of risk factors and what people were going to be dying of. So again, there were 427,000 participants in this study who reported how much fish they ate. Excuse me, This is not that one. This is habitual use of fish oil supplements. So this is in this particular study, this cohort, about 30% of people were taking fish oil supplements. So the question these investigators were asking was, in those people that were taking omega-3 supplements, was there any difference in their lifespan or any difference in the diseases they died from over that follow-up period of 10 years? And so we've got, here are the endpoints they looked at: all-cause mortality, cardiovascular, myocardial, so heart attack specifically, stroke, the cardiovascular events, myocardial infarction without dying from it, and a stroke without dying from it. And so we're comparing over 10 years people who are non-users of fish oils versus people who are users of fish oils. And what they found here in the most stringent statistical model is, again, virtually the same thing we saw in our observational study. All-cause mortality was reduced by about 13% for a 1 standard deviation increase in the omega-3 level. All of these are significant. This is 0.84 is 16%. This is a 20% reduction. This is the 13%, 7% reduction here. So this one was not, stroke mortality was not significantly reduced, but it was tended to be lower. But all these outcomes were lower in people that took omega-3 supplements than people who did not. And the authors concluded that the habitual use of fish oil supplements seems to be associated with a lower risk of all-cause and cardiovascular mortality, and to provide a marginal benefit against cardiovascular events in the general population. So there's good evidence that omega-3s are good for you. How might this be happening? This is a study we did over 10 years ago now, published in JAMA in 2010. In this study, we looked at the rate of change in the length of the telomeres. Telomeres, of course, are the ends of each DNA strand. Each chromosome has a section at the end called a telomere, and that section of the DNA strand does not transfer to the next generation. Every time the cell replicates, a little bit of that is lost. And so, and once all of the telomere is gone, once the cell has gone through that many replication cycles, that cell can't replicate anymore and it dies. And so the rate at which the telomere section shrinks is kind of a marker of biologic aging. And in this study, we looked at around 900 individuals who had stable coronary disease, and we followed them for 5 years. We measured the length of their telomeres at the beginning and the end of the study, and we also measured their omega-3 index. This side here is probably the best. If the omega-3 index was 3% at baseline, the rate of telomere attrition, the further down this graph you go, the faster the telomeres are shrinking, the faster the person is aging biologically. The higher the omega-3 index got, the slower, the less was there a loss of telomere length. So patients with the highest omega-3 index experience the slowest rate of telomere shortening, the slowest rate of cellular aging. So that can explain some of the reasons, some of the observations we made just doing fundamentally body count studies. And so there's a very consistent story here. Let's look briefly at cardiovascular disease, leaving total mortality. This is most recent meta-analysis that anybody's done on omega-3 randomized trials. So these are a meta-analysis of the omega-3 studies where people are given omega-3 versus placebo and then followed for cardiovascular outcomes. 17 randomized trials, RCT, randomized control trial. They included only the ones over 1 year duration. There's 83,000 people involved. What's important about this particular meta-analysis is they broke down the dose of omega-3 that was given in these 17 studies. Some of them only gave about 0.8 grams or less. Some got up over to 2.5 grams a day of omega-3. And then they looked over here in this figure at the risk for a variety of things as a function of how much omega-3 people were given. Now, these are the number of studies. There's not a lot of studies here, unfortunately. But you can see that particularly for something like cardiac death. When you get up to the highest omega-3 dose, over 2.5 grams a day, you have a statistically significant reduction. You have a significant reduction in total mortality. It's just not, I mean, you have a reduction, it's just not statistically significant because there's just not enough events. But all these red boxes are statistically significant reductions in sudden death, cardiac death, and stroke, as in the studies that gave the most omega-3. So there's a dose-response relationship here, a higher omega-3 intake, even in these randomized trials that aren't even more than 3 or 4 years long. They're seeing a statistically significant benefit. So here's the quote from this latest meta-analysis, considering the relatively low cost and side effect profiles of omega-3 supplementation and the low drug-drug interactions with other standard therapies used in primary and secondary cardiovascular prevention. Clinicians and patients should consider the potential benefits of omega-3 EPA DHA supplementation, especially in the 1,000 to 2,000 milligram per day dose. And I think that makes sense from the data. Let's jump to another disease, autoimmune disease. This is an interesting paper that just came out this year. This is a study that was done it's called the effects of vitamin D and omega-3 on incident autoimmune disease in VITAL. VITAL is the vitamin D and omega-3 trial. It was done out of a group at Harvard. This is a randomized trial, 4 groups. Some groups, 25% of people got omega-3 supplements, some got vitamin D, some got both, and some got dual placebo. So there's 4 groups here. Almost 26,000 people were involved in this study. The dose of omega-3 was only 840 milligrams. They used the ethyl ester form. Lovesa was the standard drug. 2,000 I used the vitamin D. They followed these people for 5 years, a little over 5 years, and they were looking for incident autoimmune disease. It was a pooling of all kinds of diseases, rheumatoid, inflammatory bowel disease, etc., and they did it all by either medical record confirmed or by probable. They were defined as probable outcomes when the doctor diagnosed it but did not confirm it with testing. So you'll see when I get to the outcomes that we have confirmed and probable. And that's what lots of these figures are about. This column over here is the confirmed autoimmune diseases. This side over here is confirmed plus the probable autoimmune diseases. So people, did they get over the study 5 years, did they develop autoimmune disease or not? And I like to look at this side, it's probably more events. Basically what you see here is the people in the placebo group. This is the rate at which they developed autoimmune disease. The yellow line, the dark blue line is the rate at which the omega-3 treated group. And again, they only got 840 milligrams. So this is not a big study, not a big dose. There was statistically significant reduction, 18% reduction in risk for autoimmune disease. And it was statistically significant. Interestingly, if you look at what we call the 2x2 factorial, this is all 4 groups, people that got the dual placebo, people got both vitamin D and omega-3. The line here on the purple or the pink dots, that's the dual placebo group. They got no treatment. And whether they got vitamin D, they got omega-3, or they got omega-3 and vitamin D, they all had about the same reduced rate of autoimmune disease. So there was an effect basically of vitamin D and of omega-3 in this trial on autoimmune disease, and that makes some sense. The authors concluded that this trial of older adults in the United States found that vitamin D and omega-3 supplementation for 5 years reduced incident autoimmune disease compared with no supplementation. And the clinical importance of this trial is high because these are well-tolerated, non-toxic supplements, and other effective treatments to reduce the incidence of autoimmune disease are lacking. This is a strong statement from the authors on this particular paper. Let's jump over to mental health. Here is a kind of a meta-analysis, a summary of studies. This is the effects of the dose of EPA and DHA on cognitive function in adolescents. All these studies were done. Each one of these bars is a study, and each one of these bars shows the dose of EPA and DHA used in this study that looked at cognitive function, one sort or another, in adolescents. And what they found was if you look across the people, the studies where over 450 milligrams of EPA and DHA were given tend to be the ones that are positive. That's the ones, all the ones with the dots at the top. You need a certain dose of omega-3. So if you're just taking 200 to 300 milligrams a day, you may not get an effect. It's important to actually get a good dose of omega-3. And the authors of this study, the title of which is said, in conclusion, daily supplementation with 450 milligrams of EPA and DHA per day, that's redundant, and an increase in the omega-3 index of over 6% makes it more likely to show efficacy on cognition in children and efficacy in adolescents. They also looked at omega-3 levels in a very few of these studies. So higher omega-3, better benefits for cognitive function for kids. This is an interesting study. I thought I'd throw this into psychotropic drug use. This is a study that was an intervention study where they gave omega-3s or placebo. But if they looked over here, the first set of columns, this is at baseline, looking at the omega-3 levels. And the people in the who had low omega-3 levels had an increased likelihood of being on psychotropic drugs. So all these, anything above 1 means increased likelihood of taking drugs, and the people who had low omega-3 were the ones who had the higher dose. And after the change in omega-3 levels after supplementation for a year, you see here the way 1 year increase in the omega-3 index was associated with a decrease in drug use. So people who were not only at baseline had low omega-3 levels were using more drugs. After a year of taking omega-3, the people who had the greatest change in omega-3, the greatest increase in omega-3 levels, had the greatest reduced use of psychotropic drugs. So there was a benefit in that regard. Very different type of question about mental health. Let's look at dementia, very important disease, Alzheimer's disease and dementia. This is a study that was published now about 14 years ago, but we've recently confirmed it in an updated study. But we're looking here at the plasma DHA levels, highly correlated with red blood cell DHA. They do predict risk of developing Alzheimer's disease. This was done in the Framingham study, the most famous observational study out of Framingham, Massachusetts. And what they did was they measured DHA levels in the blood in about 900 people in the Framingham Heart Study who were about 76 years old at the time. Then they followed those individuals for about 9 years to see who developed Alzheimer's disease. And then they compared it with their omega-3 levels. And what they found here was that if you look at the quartile 4, meaning the highest 25% of omega-3 levels at the beginning of the study, their risk of developing Alzheimer's disease or dementia was around, let's say 9% of them did over the next 12 years. Whereas people who had lower omega-3 levels below this fourth quartile developed at around twice that rate. So there was nearly a 50% reduction in risk for developing Alzheimer's disease if you had the highest 25% omega-3 levels. And again, there's no supplementation going on in these trials. These are just observations based on omega-3 levels based on diet. So there clearly seems to be a link between higher omega-3 and reduced risk for developing dementia. I'll jump over to exercise and joint pain. I'll show you an interesting study. This is a study that was done really to look at the question about omega-3 and atherosclerosis. But they also had a look at joint health. So we'll look at that in a moment. So the way this study was done, this was an intervention study, randomized trial. 285 people with stable coronary artery disease who were all taking statins were randomized to omega-3, and this is 4 grams of EPA and DHA, 4 grams of Lovesa, which provides about 3.4 grams of EPA plus DHA. So that's what this is. So again, 4 capsules of high dose omega-3 versus no omega-3s, was the control group. They gave them the omega-3s for 30 months, and their primary endpoint was looking at how coronary artery plaque volume changed with the omega-3. There's people who in placebo group, their coronary arteries developed more and more plaque over that 2.5 years. And people on omega-3, there was a retardation of the amount of plaque that was developed. But that was the main study. The primary point here is to look at physical function, because they also asked these people, they didn't just look at their heart, they asked them how their physical function was. And what they found here was this is the number of minutes of exercise per week people reported. And the control group in the black reported at baseline around 140 minutes a week, and after 1 year of placebo, a little bit less, but not much different. The omega-3 group at baseline was no different than the control group, as it should be. But after 1 year of taking the omega-3, the amount of exercise they were able to do went up statistically significantly. So there was more exercise done in people who were giving omega-3. That wasn't the purpose of the study, but that's what they found. And they quoted, the quote here from the paper says, high-dose EPA and DHA may benefit coronary artery disease patients by preserving physical function, increasing the amount of exercise, and reducing joint replacement. EPA and DHA may be safe preventative strategies against musculoskeletal systems in CAD patients. And here's an observation that they made. It's a very small one, but it's interesting. After 30 months of treatment, 11 control subjects had a knee or hip replacement, but only one in the omega-3 had a replacement. So that is, they're trying to follow up on this study because they can't do it. They couldn't, this is statistically significant, 0.002, but the sample size is very small. But it'd be very cool if we could show that omega-3 treatment would actually prevent the need or postpone the need for joint replacement. But that's what this suggests. Okay, eyes. Well, we're moving all around the body here, but that's the whole point. Here are data again published just in 2020 from again the VITAL study. I mentioned this earlier, the vitamin D and omega-3 trial in 25,000 people. Now here they're looking for the incident age-related macular degeneration in this study that was done again in people who were over age 50, given either vitamin D or omega-3 or both. And they followed for the development of macular degeneration as well. And interestingly, this is the rate at which they developed all the 4 different groups. This blue line is the rate at which the omega-3 group developed macular degeneration. It's the lowest rate of all these groups. Vitamin D alone was a little bit, not quite as good as omega-3. Interestingly and provocatively, the group that got vitamin D and omega-3 had a rate of macular degeneration that's the same as placebo, which doesn't make any obvious sense unless somehow these two cancel each other out. But the important thing for this talk is those who were taking omega-3 had the lowest, slowest rate of developing macular degeneration, 27% reduced risk. So that's another good thing that the omega-3 is for. Have to talk about COVID-19. It's getting a little bit in our rearview mirror, which is nice, but it's certainly occupied us deeply over the last couple of years, obviously. This is some interesting data that came out last year about worldwide fatality from COVID versus the omega-3 intake in all around the world. So these investigators looked at 6 different regions around the world, 22 countries in the Eastern Mediterranean. This is all from WHO data. Many countries in Africa, 34 countries in the Americas, Europe, South. So there's 6 different regions they looked at. And they looked at the rate of death from COVID. And they also looked at the reported amount of omega-3 fatty acids that are in the diet of these different regions. And if you look on this axis, on the y-axis, we have the regional fatality rate from COVID. And on the x-axis, the average marine omega-3 fatty acid intake. And interestingly, the higher the omega-3 intake, the lower the risk for dying from COVID-19. This certainly doesn't prove that the omega-3s are doing this, but it's a very interesting observation that there may be something to having a high omega-3 that makes you more resistant to developing COVID or dying from COVID. We published probably the first paper that looked at real data on omega-3 and COVID. This was a study we did with a group at Cedars-Sinai in Los Angeles. They had collected blood from 100 patients who had been admitted with COVID, and they banked that blood, and we were able to measure the omega-3 index in those 100 samples. The average age of those people was 73, about 60% of them were men. The omega-3 index average was only 5%. This is not surprising. This is Southern California. Very few taking supplements. And what we looked at was the relationship between blood omega-3 levels and risk for death from COVID-19. And complicated table here, but if we really just focus down on here, this is risk for death by quartile of omega-3 index. And if we compare omega-3 index in quartile 4, meaning the highest 25% of people, to the omega-3 index, people who had an omega-3 index less than that, quartiles 1 through 3, so the lowest 75% to the upper 25%, we find that the odds of dying in the hospital were 0.25, which is statistically, not quite statistically significant, but almost. And in the early days of the pandemic, we were publishing anything we could find that would find a benefit in reducing risk for COVID death. And so we were able to publish this paper, even though it was not statistically significant. The trend was very strong that essentially people who had higher omega-3 levels were 75% less likely to die from COVID than those who were not. So there is certainly a connection here. What might be the mechanism of action? What is the potential protection against COVID from higher omega-3? Probably relates to the omega-3 fatty acids being the producers of what we call pro-resolving mediators. These are compounds that block inflammatory storms. We've heard of the COVID, it wasn't icosanoid storm, what the term was, I'll get it in a minute, cytokine storm, that's it. How can we forget? So here is just a cartoon of how this is a situation where there's very little omega-3 on board. You get a damage in the alveolar. You get icosanoid storms that produces cytokines that cause inflammation and brings in white blood cells that causes swelling of the tissues and hard to breathe. If there's omega-3 on board, there's a variety of mechanisms that can block these inflammatory responses and explain the benefit of the omega-3s. So this is again theoretical, but it does make perfect sense. Here is another very novel possible mechanism of action by which omega-3s might protect against COVID, because we all know about the spike protein. The spike protein is what's on the COVID viral coat, and that is what binds to this ACE2 receptor, which brings the virus in the cell where all the trouble is caused. So people with a low omega-3 intake, there's plenty of opportunity to bind that spike protein. But the spike protein can exist in two different forms. It can be open or closed, or locked or unlocked. It turns out that when omega-3 levels are high in the body, the spike protein is actually in a locked conformation, and it will not interact with the ACE inhibitor, the ACE receptor, reducing the amount of the virus that's actually taken into the cell. So that, and of course, that would have all the downstream effects of less inflammation and less disease. So it could be because something in the omega-3s affect the ability of the virus to actually be taken up, can reduce that. So that's kind of a novel idea that there's some evidence for, and that may be the mechanism. So we take a breath. We can just look back at what we went through. I think current evidence strongly supports the hypothesis that higher levels of omega-3, higher intakes, which mean higher blood levels, slow the rate of aging. They reduce the risk for premature death. That's kind of saying the same thing twice. They can help lower the risk for autoimmune diseases, slow the development of dementia, improve joint health, and make exercising easier, less painful. They may preserve macular function over time, and they certainly may protect against the adverse effects of COVID. So with that, I think I will show you the Mount Rushmore from the other side. Not really, and end the program and give it back to Chris.
Oh, thank you, Doctor. That was fantastic. I learned so much. If you don't mind proceeding to the next slide. So at this juncture, we're going to take questions. If you have any questions, just please type it into the questions area of the interface in the GoToWebinar control panel. We do have one question from Lori Kaplan, and the question is, what is the current recommendation for omega-3 supplementation with ApoE4 gene variant?
That's a great question. So the general idea is ApoE4 gene variant will increases risk for dementia. And therefore, if omega-3s are protective, is there a need for a higher omega-3 intake to protect against that higher risk of dementia? And we don't know. Short answer, Lori, we don't know. But we do have evidence that that actually is true, that people who have ApoE4 are less, let me put it this way, higher omega-3 levels do protect against developing dementia, but if you're ApoE4, the protection is less. That implies that you need a higher dose. I would say my gut feeling would be somewhere in the neighborhood of 1,500 to 2,000 milligrams a day of EPA DHA. If I were in that situation, that's what I'd be taking.
Okay, here we go. Another question from Lori. I thought I had seen some paper that stated high supplementation could be inflammatory, but I don't recall the paper.
I don't either. It doesn't make any sense to me, and I can't remember any papers that have suggested higher omega-3 levels are pro-inflammatory. So maybe there's something I missed or that was misunderstood in the press release. Can't help there.
No problem. She says, okay, thank you. Another question from Charles Ardent. I heard that monoglycerides are faster than triglyceride omegas at raising omega-3 levels.
Yeah, there are some omega-3 products that are, instead of a triglyceride, they're a monoglyceride. And they might be a little better absorbed. I think at the end of the day, if you can look at a 24-hour absorption curve and see something that's absorbed faster than another one form. But if you look after 4 or 5 months, at the end of the day, you typically don't see much difference at all. If something's absorbed by 4 hours with one form and 6 hours in another form, it looks nice on a graph, but it doesn't really make a lot of difference in the end. So I wouldn't put all my eggs in that basket.
Okay, great. Thank you, Doctor. Quick question that I can answer. Tawny Pendleton, when will the recording be available and when will it be emailed, or should we check the website? No, we will send you through the system to all viewers and all registered attendees the video. Probably you will get a link on Friday, possibly sooner, but it will no later than Friday. So that's an answer to that. Any other questions from the gallery?
Well, actually, Dr. Harris, Dr. Sedano here. One quick question that I have for you. Tell the audience your opinion on the difference between measuring whole blood fatty acids as opposed to the RBC membrane, red blood cell membrane.
Yeah, when we do our assays, we usually get a dried blood spot, which is whole blood. We analyze the omega-3 content of that whole blood, and we then use a equation to convert that to the red blood cell equivalent. They're very, very highly correlated. So it's a very strong, we have a lot of confidence that even though we're measuring whole blood, omega-3 levels, we can tell you what the red blood cell level is from lots and lots of comparisons we've made. So that's what we do. Certainly with dried blood spots, if people send us blood tubes, we will actually isolate the red blood cells and analyze them. But I think those are both good ways of looking at the omega-3 level.
Thank you, Doctor.
Thank you for that, Dr. Sedano. Okay, so with that, we're going to conclude our question and answer period. So if you, Dr. Harris, if you wouldn't mind proceeding to the next slide, we're just going to go over a few Avexia housekeeping here. So we just want to make sure that everyone's aware of the Ask the Doctor service that is free to Avexia clients. That's headed up by Dr. Sedano, who you've heard tonight. He will review test results, do interpretations, clinical conditions. He'll recommend further testing. The service that's free is a email submission. You take the test results and you attach it and submit it. Once you log in to the Avexia Link platform, you'll see it on the left side, quick links, Ask the Doctor. You click there, you'll have the free option, and then there is a live video option for a small fee that you can also, if you want to interact directly with Dr. Sedano. So we just want to make sure that you're aware of that. Doctor, if you wouldn't mind proceeding to the next slide, please. Great. Okay. And now, of course, that we've learned so much about omega-3 and the omega-3 index, I would like to review how to order the testing from Omegaquant before concluding the webinar. First, you'll need to log into your Avexia account and go to the Avexia Link ordering banner, which is, again, on the quick links on the left. Select a patient or create a patient to assign the test to, and then you'll want to select specialty labs, then select Omegaquant. Find one of 3 Omegaquant omega-3 related tests, plus there are other Omegaquant tests as well, but omega-3, there's 3 versions. And finally, complete the test by clicking the green place order button. It's very simple. So there, you now are aware of how to get the testing. Doctor, if you wouldn't mind proceeding to the next slide. And for any questions or issues you may have, contact Avexia Diagnostics by email at info@avexiadiagnostics.com or by phone 5 days a week at extended hours, 8 a.m. to 8 p.m. Eastern Time at 888-852-2723. A recording of this webinar will be available, as I said, by email in the next few days, by Friday, absolutely. If you don't mind proceeding to the last slide, Doctor. So thank you, Dr. Harris and Dr. Sedano, for this informative presentation. Thank you all for joining us for this webinar event. Until next time, from everyone at Avexia Diagnostics and Omegaquant, stay healthy, stay safe, and we wish you all the best on your pathway to wellness. Thank you, gentlemen.
Bye-bye. Thank you.
Thank you, Dr. Harris.
Thank you.
Thank you.
Bye.